A Hall-effect thruster is a type of ion thruster used in spacecraft propulsion in which the propellant is accelerated by an electric field. Hall thrusters or Hall current thrusters are terms used to describe Hall-effect thrusters. Hall-effect thrusters use a magnetic field to limit the electron's axial motion and then use them to ionize propellant, efficiently accelerating the ions to produce thrust. Hall thrusters operate on a variety of propellants, the most common being xenon and krypton. Hall thrusters are able to accelerate their exhaust to speeds between 10 and 80 km/s, 1,0008,000 seconds of specific impulse. The thrust produced depends on the power level. The electric potential, electrostatic potential, is defined as the amount of work energy needed to move a unit of electric charge from a reference point to a specific point in an electric field. A radial magnetic field is used to confine the electrons, and the combination of the radial magnetic field and the axial electric field causes the electrons to drift in azimuth, forming the Hall current from which the device gets its name. The central spike forms one pole of an electromagnet and is surrounded by an annular space, and around that is the other pole of the electromagnet, with a radial magnetic field in between. The propellant, such as xenon gas, is fed through the anode, which has numerous small holes in it to act as a gas distributor. As the xenon atoms diffuse into the channel of the thruster, they are ionized by collisions with circulating high-energy electrons. The xenon ions are then accelerated by the electric field between the anode and the cathode. The thrust is very low in comparison to chemical rockets, and it operates at the high specific impulses that are typical of electric propulsion. Another advantage is that these thrusters can use a wider range of propellants supplied to the anode, including oxygen, though the cathode must be easily ionized.